Okay, so with this lecture, we're going to look at reading drawing sets and just some of the different components that go into different drawing sets. A lot of what we're going to look at today, or what's related to what we're going to look at today, was covered in that last lecture about symbols and drawings. So it's important to make sure that you have watched that one and really understand it well, because a lot of those symbols are going to come back again. And we are going to review some of that stuff again today. Now, in addition to that, we're going to be looking at a lot of different kind of sets of plans as just examples to look at. And so linked right here in the presentation, and you can find this presentation on As You Learn, is just a link to a Google folder that has several other folders in it with all different sets of plans, because we're going to look at quite a few of them to really understand that some things you can make stylistic choices about, straying from the exact standard, but it's still important to follow the standards that are set forth by the NCS, or the National CAD standards, because that is what's really going to be something that everyone is following through with. So I just wanted to link that there so that way you can feel free to look at these plans yourself if you feel the need to, or if I don't zoom in um, well enough for you to be able to see everything. So to start off with, I just want to review again the different types of lines that you might see in sets of drawings. So we've got our continuous line, or our just regular visible line. This is showing our object edges. So things like our outside and inside of our walls, the edges of our doors, the windows, the cabinets, furniture plans. Lots of different things are going to be done with a continuous line. So the important thing with a continuous line is the line weight, of how thick or how bold that line is going to be. Then we'll also see dashed lines in our plan. So dashed lines are used to show features that are below our current line of sight, or our current view. So dashed lines are typically used for things like footings or foundations, things that are below our line of sight, and they're just a larger version of dashes compared to the hidden line. So a hidden line is shorter dashes, and they are used to show things that are above or behind our current line of sight. So we would see hidden lines used for things like upper cabinets, or the rest of the staircase after it goes above where a floor plan cut is. In elevations, we'll see hidden lines be used to show things like rebar, or excuse me, in an elevation it would be used for the top of the floor and the ceiling height. In a section view, it would be used to show things like rebar, or different features that might just be kind of hidden away, thus the name hidden. Center lines are used to help grid out a specific drawing set, or to show symmetry between different parts or pieces, and they can be used to help kind of clean up dimensions. And then lastly was our phantom line, or our cutting plane, which is used to help show boundaries, particularly within our site plans. And then it can also be used to help show where cuts are being made for sections. And then line weight is just determined by the thickness of each of these lines. Now again, where each line is used and the particular line weight, those are all set forth by the National CAD standards. So that's going to be a big thing we're going to look at today, or at least speak upon today, because we can't go through all of their documentation. But they are the kind of the set, for lack of a better term, standard for what we would use and how our drawings are going to look. And they're put together by the National, I believe it's the National Building Science Institute, but I could be saying the exact name of the organization incorrectly. And then again, in our different sets of documentation, we're going to have different types of views. So we're going to have our plan views, which are that cut horizontally through our building, so that this way, if we were looking from above, we can see the different spaces as well as the walls, the thickness of each wall, and even a little bit of the material for it. Plans are a big portion of what is going to go on in our drawings, because that's where we're going to find a lot of the dimensions, a lot of the measurements for our building as we are getting ready to construct it. Elevation views are then depicting the building from the outside, from each of the cardinal direction or from each particular wall. Elevations really help us get an understanding of material finishes and all of the different exterior notations that are going to be important for what the building looks like from the outside. And then section views are a vertical cut. So if plans are a horizontal cut, section views are a vertical cut. So we can understand the differences between volume of the building, and we can understand a lot more about construction details coming from that section view. Then any of these style views could also be depicted as a detail. So you can have a zoomed in detail of a plan where you're just zooming in to get more information about a particular section. And some of the ones we'll look at today, we have plan details, just because they're such large buildings that it's going to be difficult to see them and add in all of the different annotations and measurements in just the one floor plan. You'll also have details in section views, and that's a lot of what details come out from. And it'll just show maybe parts that are atypical will have details with them, and then you'll also have some typical detail work for things like how the stairs might be constructed or how the foundation is fitted to the wall or the floor, depending on the type of construction. Other types of views you'll see too are renderings, and so renderings are 3D realistic pictorials of the building to help kind of sell the building if it was still in the bidding process, or to just kind of help put something on the cover page to make the sets of drawings a little bit more appealing. And then another thing you'll see in a set of drawings would be things like schedules, though those are not a view, so it's not a drawing. It is just a tabulated chart to then help define all of the different components that are being inserted or used in the building itself. Now, in a set of drawings, they are always going to have a title block, and that title block is always going to be located on the right side of the sheet. So if this was just a set of Architecture D paper, so we're always going to put it in landscape, where we've got our longer dimensions. So this would be 36 by 24, and our title block is going to be on the right side. And that is primarily because when we go to store these drawings, if we're rolling them up, we're going to roll them up with the drawing side out, so that this way the title block is going to just sit on, after it's all rolled up, title block is there. I don't have to unroll the drawing, and I can easily get information. The other reason why we roll it drawing side out is that way when we go to unroll it and lay it flat to read it, it's actually going to stay flat, versus if we rolled it the other way. But in the title block, you're going to have information about the project itself. So it's going to say, what this building is and who it's made for. And then there's also going to be information about the architects or engineers and designers that were included on this project. Information about the time spent on this set of drawings. So maybe if there were multiple iterations of a set of plans, that would be included in here. So we would have information about our designers, the project, and then information about, this is revision number 3 or 4. Just that way we can just kind of track if it's the latest set of drawings or not. And then information about the particular sheet. And this is what we're going to focus quite a bit of time today on, is just being able to identify the sheets and know which sheet types mean what. So this area right here in the lower corner of the title block is a very, very important area for it. This area is going to be what changes and updates and is going to be different on each sheet. The stuff right here is pretty much going to be the same no matter what on a project. So for the sheet information, it's going to be based on a letter and then a set of numbers. And a couple of people will do this number designation slightly different, but the letter and the number is still going to be using this same kind of different format, but maybe instead of having it 101, they'll do 1 dot, and then they'll number them 1, 2, 3, 4. I personally think this way is the better way to do it. This is also the way that's set forth again by the National CAD standards, and I do have linked right here just a little brief look into the National Institute of Building Sciences. Excuse me, that's the name of the organization. But this then is looking at the National CAD standards, and this is taken just directly from their documentation, just a little snippet from it, where it goes over how everything should be labeled and numbered. Now, the purpose of the National CAD standards is so that way all designers across America are using the same system for labeling all of their sheets, for putting all of their different layers of different line types into the computer. So as things perhaps are shared from one designer to another or sent from the designer to the contractor, there's going to be less confusion if every single designer is doing it the exact same way. And so that's the purpose for the National CAD standards. But we have here of just kind of how to label the first part, which was the discipline designator, and that's just going to say what type of drawing is this. Now, most often it'll be an architectural drawing, so it'll start with an A, or a structural. Civil is another big one. Mechanical, electrical, plumbing. You're not necessarily going to need to use every single one of these. And it's going to depend too on whether or not it is a commercial project, something that's open to the public, versus a residential project. Because if this is a residential project, I don't need a hazardous materials sheet to go along with it. But if it's a commercial project, I may need I'm going to need the hazardous materials. I'm also going to need fire protection. In the case of, we're going to look at the high school set of plans, well, they have a life safe plan, pretty much of just kind of like, well, how would a person be able to leave the building? So all of these different things are put into place. And then after that are a series of numbers, and then those numbers are going to designate what type of drawings are located on that sheet. So if the number starts with a 1, it is a set of plans. It starts with a 2, it's an elevation. 3 is section. 4 would be zoomed in details of plans, but just large scale views, so not necessarily a detail. So I know that's a little hard to grasp the difference between. 5 is details. 6 is then your schedules. 7 and 8 don't have any definition by the National CAD standard, so you can then, as a designer, pick what you would want for that. And then 9 would be your renderings. Then after that, the next set of numbers, so the first number in that 101 is what's going to then determine the type of sheet, and then the numbers after that just would determine the sequence, whether or not it's the first, set of plans, the second set of plans, the third, the fourth, so on and so forth. So A101 would mean that this is an architectural sheet and that it is a set of plans, most likely going to say it's the floor plans, and then the O1 would mean that it is the first set of floor plans. So it's probably level 1 if we have multiple levels, and then if we have a level 2, it would be A102. And then if there was a third level, there'd be A103. Once we get all of our set of plans in there, then we can move on to sheets for elevations. So that would still have an architectural discipline, but then it would be 201 and then 202, so on and so on as we go through them. So to look at some of those here in the ARC scans, I've got a couple of folders already open, and these are sets of plans for the current high school. But one thing to keep in mind is that these are not the most up-to-date set of plans, so I could never find a set from 2010. I could only find a set from 2008. So some of the plans are a little bit wonky in here. These were not the plans used for construction. But we're just going to look at some title blocks and then just a couple of little sheet designators. So off the bat here, I do have a cover sheet, and a lot of sets of plans will come with a cover sheet. Just please go away there. And the cover sheet can stray from that title block requirement. So here is the cover sheet for the high school. The title block instead is kind of coming up over here. And then we have the volume of all the different drawings. So it's kind of like a table of contents. So every single line that's on here is a different sheet of paper that comes along with this. So you got to think this is a pretty large building, a pretty big school here. And so every single one of these is its own sheet. And like I said, we've got a couple general sheets. There's that life safety one. We've got civil engineering plans. And so these are things like our site plan. These are our paving, our utility plan, all of that stuff, erosion control, things that have to deal with the area. And then architectural, or the area and the environment. Architectural plans, then we have our floor plans, our elevations are in here. Now, I'm not a huge fan of this architect's designating system because I do think it strays a bit too much from the National CAD standard, but I'm not there having a say with them. So for instance, with their 2 designator, they start with their roof plans, and then they use their 3 designator as elevations, and then their 4 as sections. Not a huge fan of it, but this cover sheet then can at least help you understand it. So that way, even though it's going off of what that typical use is, we can still understand what's happening. And then we've got our interior elevation. So every single one of these sheets is just a different sheet of paper in the set of plans. So if we look at just a regular, let me organize this by name to make it easier. Just like a regular set of architectural floor plans, we've got here a 101, which to me says it's architecture. It's going to be a plan style view, and that this is most likely going to be the first floor. So if I double click on it, and unfortunately I got to click print every time I want to rotate, here is, if I look at my title block, it is sheet A101. It is the first floor overall floor plan for the high school. And so we can see here then that it is designating the overall layout of the high school floor plan, where the different parts or pieces or the different rooms are, door placements, staircase placements, and there are some measurements included on here. So measurements for like this part of the hallway, these locker rooms. but there's not a lot of measurements on here just because this is a massive, massive plan. We also have those center lines used for gridding out our different spaces. But if we tried to put every little measurement on here, it's going to muddle up this plan and make it really, really hard to read. And that's even why here on this little key, they have it kind of designated to say these different areas. And it's even saying, hey, if you want more measurements and details about this second wing, area 2, go to sheet A 1.12. And so then if I go to my plans and I go to sheet A 1.12, I gotta hit print. And let me just orbit myself around. So now we have a lot more information regarding measurements and details. And we also then have our, where's our little view name? Here we go. So it's saying it's first floor area 2. It's the enlarged floor plan. It's letting us know that it's done at 1/8 of an inch equals a foot. And it's giving us a north arrow. And then we have a lot more measurements about like how wide this door is, about how far this door is from the other one, how wide the entire room is, what this wall is made out of. And a lot of them too are tagged with different wall types, different door types. We have tags on our windows here as well. And then we've got different symbols for said doors and windows. So if we zoom in, here we are, creepily enough, in my classroom here. So we've got our different door tags, we've got our different window tags. We're able then to even see some information about the furniture plan. We're able to see information about this structural post, and it's saying go look at view 8 on sheet A 1.21. So we've got all of those different symbols happening, all of these different line types still in play. But I am getting off topic. I do realize in that what we want to do is focus on the title block. So this title block here is styled the exact same way on every sheet, and it has the view title and then the sheet designator. Versus if we go look at an older set of plans, so these then are from the old high school that is now demolished. It's now a parking lot owned by ASU. But so these are sets of plans from the old high school. Like I said, these ones I think are really cool, even though they scan really poorly, because all of these plans are done completely by hand. And here's the title block on the edge of the sheet. I'm just not going to bother rotating it for you guys. But again, it has a sheet identifier right here. It's letting us know who drew it. It's letting us know the name of the architects and the engineers that worked on the project name, the sheet number, the sheet designator. And then if I go look at this section view, again, it's telling me the view designator, the information about the title of this view, and then this is all going to remain exactly the same. Versus if I look at this set of drawings, and so we'll look at the cover page from this one. The cover page often will have the title block just in the same way. But here then is a cover page for a set of kind of like apartments, I believe is what's happening in this one, if I'm pretty sure. But it's been a while since I've looked at this set, if I'm honest. So again, it just has that this is the cover sheet, and it's got a sheet designator here, what the name of the project is, and who's in charge of it, and then it's letting you know for each sheet which each one of them is kind of doing. And then if I opened up one of these sets, I could look at it and I could see that this is the second floor plan, this is the sheet number, and then in all of those different symbols, it has information about which other sheets to go look at. Again, not crazy about their sheet system just because it doesn't go by that national CAD standard that I think you guys should be using, because if everyone has it standardized, it's going to make things a lot easier for everyone looking at them. And again, here's that lake house from last class. So this one, again, we have our title block on our side. It's still stylized a little bit different, but it has all of the same information. It's got information about the architects who are in charge of the project. Any revisions or date information would go right here. We've got information about the project itself, information about what's on this particular sheet, and then a sheet designator. So all of that can be found in our title block. And then, do I expect anyone to memorize this stuff, 3 weeks into a course or 4 weeks into a course? No. But I expect you to follow it as you progress through this course and through the rest of your classes. And all of it, again, can be found online. And this actually was taken right from your reading in the AIA student handbook, this picture. Now for view placement and setup of views, so again, that title block area should always be on the right side of your drawing, and then taken directly from the National CAD standards. Again, we want to be a little bit just like cautious and have some foresight with our views. This can take some mocking up of things, so that's often why I encourage students to do things on tracing paper or graph paper and then transfer it to a final version, because you're never going to be able to center everything or get the layout perfectly the first time around. And so that's why it's good to just kind of mock out or plan different areas. One thing you'll see here, and we can look at too in the high school set of plans, is it's also a good idea to grid out sheets for particular sets of views. So this way, then you can just kind of add in small details or add in your elevations one on top of another one, and then have them aligned with each other too. You might not use all of the space, and there could be sometimes ways of just thinking, oh, I could have fit, this should really be going over here, but it needs to be placed here. You want to just try to make sure you're aligning everything as well as you possibly can. So again, if we look at some sets of details, and I know that there are some sets in here that have lots of blanks in them. So here we go. Here is a set of section, or rather construction details for doors and windows in the building. And so they all are just kind of gridded out. Not every single space is being used, and that's okay. And that's in fact why some of these titles are just in the sheet itself. It just says that, the title, and then it just has a little X in here. And that's just because this was made out of a template that the architect was using. And then when they go to put their final plans together, they'll just cut all of that stuff out. But this way, everything is kind of nice and neatly lined up. The boxes, totally fine to leave them there on it, because also then it's going to just help understand that this is separate from here. So this is just one way where you can grid your drawings out. Another thing I wanted to look at too is a sheet that had elevations on it. So here are some elevations. Whoop, there we go. And so what I want for you to notice is that, but unfortunately there aren't too many where they do, where we're sitting at the same, because this, I wanted to show how these lined up, but they don't. Poopy. Oh man. Hold on. Let me see if I can find the elevations where they are lined up. I could have sworn they were. We can maybe look at the field house. If I remember where the field house is in these sets. I think this is it. Yeah. So, okay. So this is the field house, little snack bar outside the football stadium at the high school. We've got our edges of our building lined up from view to view. The section view as well, lined up. Section from the side, from a section from the, um, or rather a section longitudinally, a section transversely, lined up with each other, just to kind of help understand how these views are relating to one another. I think it would be a better idea to as well have this section down here to help understand how these ones are lining up with each other. Again, they could have moved that after the fact because these definitely aren't the final set of plans, especially because I noticed the other day when I was looking at them that all of the numbers on this one are backwards. And that's because they took this drawing and mirrored it, and then that made all of the numbers backwards, which I thought was kind of funny. Um, so we are just kind of trying to almost fit all of the different drawings in on a puzzle as best as we possibly can on sheets. You don't want to overcrowd it and you don't want to leave anything out. So it's a very weird puzzle piece game to play when you are mocking up where the different places are going. On a set of hand-drawn plans, you're again just kind of making almost quite literally a cut and paste job where you are planning different out where different parts are going and then seeing what can fit, what lines up, what doesn't. With CAD and BIM work, it can be a lot easier to do because you are using the computer to just drag and drop your different views in places. So if you don't like how they look, they're a lot easier to change and move around as you need to. Now, again, in lots of your different drawings, you're going to see different materials, you're going to see different hatches, and those hatches are going to vary. Those patterns are varying based on the materials. Linked here in the presentation is just that sheet that goes over different hatch patterns, and you can also look at ARC Toolbox for different patterns that are used in drawings for materials. And then we're seeing lots of different reference marks. So especially in that set of plans for the high school, just because it's a huge building with lots of different sheets, there are lots of different view designators. Now, interestingly enough too, again, since it's not a finalized set of plans, there are some of these identifiers where there's no information included because the drawing hasn't been made yet, but still there's a nice little placeholder identifier saying a section needs to go through here. So it just has a bunch of X's sitting in it. And there's also even some of them where it has the view identifier and it says, go look at this view on this sheet. And then you go to that sheet and the view hasn't been drawn yet either. So they aren't a perfect set. But we've got lots of different reference marks to help understand our drawings. So right from the bat, right off the bat rather, I can see here, this is an elevation with a north arrow. North arrow shouldn't exist in elevations unless they're trying to infer that this is just for, like, for all drawings, north is always at the top side of the sheet. Really, this should only be on plan style views, but yeah, they're not even trying that because it's not on this sheet. So that is just, there was probably a plan here. They got rid of it, put an elevation here, and forgot to take this off. That'd be my bet. But just to look at some of these view identifiers, we'll go to plan view, and we'll spin the building, the page around. It needs to spin one more time. There we go. So here we are, we're on the 3rd floor, and we've got all of these section cuts. So this is saying if I go look at view 4 on sheet A4.12, I'm going to see the section cut right here. This, since it doesn't have that tail included on it, this is an elevation marker. So it's saying go look at view 3 on sheet A3.11, and you'll see the elevation of this side of the building. This is a section cut, but it's also offset to just kind of follow the little angle that this portion of the building makes. So again, it's saying view 1 on sheet 411. So these are all different section designators, and this is an elevation. We don't have any door or window tags on this set of plans because this set of plans is done at a 1 inch equals 20 foot scale. So it's a very small scale, and we can't fit all of those little tags in there on these tiny doors. And that's why we see those tags for when we looked at the enlarged set of plans. And even then, this one will have a key as well that has all of the different areas designated. And the numbering scheme they have for these areas, to me, makes a lot of sense, in that this is the first wing, and so it's saying go look at the plan for third floor first wing, third floor second wing, third floor third wing, and then our different little areas for the science departments and whatnot. So if I go to look at some of these, so let's hope we'll look at this elevation. So I'm going to go to view 1 on sheet A311, which hopefully is actually there. Or hold on, did I read the wrong sheet? Oh, uh-oh. Did I? 311. Okay. Here it is. Okay, I was looking up here and I went, uh-oh. Because like I said, some of them aren't in the set of plans like they should be. Whoop, whoop. Okay. So if I go look at view 1, here it is. View 1 on sheet A311 is looking then at that side of the building from the outside. And just to kind of help explain from the plans then, is this is that back edge with the classroom, is what we are seeing right back here. This wing ends right at about this, and then the second wing and third wing are longer. So that's why in the set of plans this looks like kind of shorter, but then we can still see all of this back here. If I'm looking at this side of the building, I can still see that behind it, which is why it just looks a little bit longer. Then we have some section identifiers still telling us, like, go look at view 2 on sheet A416 of a cut through the building, looking at this portion. And we also have a detail marker too that's saying go look at view 7 on sheet A312 for a detail about this area. And we also have a lot of material designators or material tags. So all of these little leaders with the circles next to them, or the ovals, rather than labeling it with the material that's on there like we saw on some of the other plans, they're just saying, you know, this is material number 5. And then we can go look here at the material legend and just see what material 5 is, because otherwise these sets of plans are going to get really, really cluttered quickly. So again, I feel like we went through a lot of the symbols pretty well last time, so I don't want to spend too much time on them, but we can still see a lot of those different line types happening, a bunch of different symbols going on. The more you practice looking at the symbols, the easier it can be to remember them. And I know that's not a helpful tip for you, but that's the tip you're going to get from me. Now, dimensioning. So dimensioning is the system of measurements that are used in a set of plans, And dimensioning is going to vary based on whether it is wood framing or masonry framing. And the big difference is how we dimension openings in our building. So if we are framing out of just stick framing with lumber, we dimension to the center of openings, so things like the center of our windows, the center of our doors. With masonry framing, we measure from outside to then the other outside of the opening. So instead of measuring to the center of where the framing of the opening would be, we measure just from outside to outside of the rough opening. So the reason why we do that is because if I am trying to estimate and figure out how many bricks I need to buy, I need to know kind of for where that opening is going to end and where it's going to start. Now, we always want to place an overall measurement from just the very outside of the framing to the very outside of the framing. And so one thing to keep in mind when we do lumber-based construction is that the face of the frame is different than the absolute exterior of the building. And so your wall, and we'll go over this a little bit more next lecture, but your wall, it's made up of those several different pieces or several different materials, and you're usually going to have your outside siding, and then your sheathing, and then your frame. And so when I'm taking, in this case, this 24-foot measurement, it's not if I took a tape measure to my finished building and I measured from very outside to very outside, it's 24. It's if I took a tape measure and measured from the face of the stud on this west wall to the face of the stud on this east wall is 24. So all of these measurements are taken directly from the frame, not from the finished exterior. Same thing then is going to be happening too with your masonry work as well. We're also, with dimensioning, seeing some different line types going on here. So we have our center line, again, running here to help with our dimensioning, to help show alignment of features. So this is letting me know that this door on the south wall is in line with this window up here on the north wall. So that way I don't have to put a measurement here saying for this door, because I have that measurement here. Same thing then is happening with this window, is it's saying that it's 4 feet from here, and that way I can just use the measurement or borrow it from where I have it. Yeah. The other thing too with your dimensions and your measurements, and we'll go over this when we look at the using a scale and just setting things up, is it's always a good idea as a designer to use whole numbers when you are dimensioning things and figuring out where you want things placed. And what I mean by that, and hopefully it's pretty obvious, is you want to make sure that you're doing just full feet or at least feet and full inches, that you're not measuring anything to be 5 foot 7 and 3/16 of an inch. And that's just because it's going to be really annoying for the person building the house. So if you go to place your dimensions, particularly when you're in software like Revit and you're getting weird numbers for your dimensions, move your components, move your pieces around to make those numbers friendly for the builder. And it's going to make everyone's job so much easier. It's going to make your drawings cleaner and nicer to look at. And in this grand scheme of things, it is not going to matter if your window is moved over 7/16. Nobody is going to notice, but it's going to make it just so much easier for people who are trying to do their job of constructing the building. So just try to use friendly numbers. Now, working with a scale, we need to think about how that scale works and what its job is or what its function is in our drawings. So the scale, its purpose is to shrink a drawing down proportionally to fit on a sheet of paper. Even if we're using really large sheets of paper, we still need to shrink a building down to fit on it. So how your scale works is that each side of it has 4 different options to scale your drawing. and you have two scales running in opposite directions. So in this case, I have a scale of 1, a quarter, an eighth, and a half. What these designators are actually doing is they're telling us how many inches on paper is equal to a foot in real life. So this half actually means a half of an inch on paper is 1 foot in real life. And those view names underneath all of the different views on the sets of plans, that's what they're referring to, is when they say a half of an inch equals a foot or a quarter of an inch equals a foot. So this would be 1 inch on paper is 1 foot in real life. I've got my scale then. This one's running left to right. This one's running right to left. And then you can also tell based on if the number is lower or if it's higher, which one of these kind of sets of numbers is associated with it. So since this 0 is lower, it's this 0, 2, 4, 6, 8, 10, 12, versus this 0 being higher up. The smaller numbers are the one associated with this eighth of an inch equals a foot scale. So we've got 0, 4, 8, 12, 16. So what these are then referring to is this would be 1 foot, 2 foot, 3 foot at 8 inch equals a foot scale. This right here would be 6 feet at a quarter inch equals a foot scale. So as I mentioned, those larger numbers, those are your feet marks. And next to the scale identifier is a 12-inch ruler in that scale. Each of these small tick marks is the equivalent of an inch. Sometimes those can be broken down even further if that scale is large. So if I'm using a zoomed in scale, like an inch equals a foot, so this would be used for like a detail or maybe a section detail where I can get a lot more detail into it. If I'm doing a quarter inch equals a foot, I have 12 little lines here, and each one is the equivalent of an inch. At this scale, though, I've got way more than 12, and so this would be 1 inch, this would be 2, and it can even then break down into half of an inch, and even then a quarter of an inch in scale if I needed to put a lot of detail into the drawing. So I can fit a lot more information easily in this drawing than I can in this one. And so that's why we have the different sizes for them. Now, they're always going to be running in those opposite directions paired with their half equivalent. And that's just so we can borrow tick markers to put less labels or less numbers on the drawing. So I've got the quarter and the eighth, the half and the 1, 3/8 and 3/4, 3 versus 1/2, 3/16 and 3/32. And then this could also be the equivalent of 1/16 equals a foot, but a lot of times we'll just use this as a full scale ruler, this side going on it. Now, with that half equivalent, we can then label less of the tick marks, and we can also borrow from the other side of it. So even though on this 1/8 inch equals a foot scale, we only have every 4 feet labeled, so it goes 0, 4, 8, 12. We can borrow this tick mark from the quarter inch scale to represent 1 foot on this 1/8 of an inch. So from here to here on paper is an 1/8 of an inch, but in scale it's 1 foot. And then this would be 2 foot, 3, 4, 5, 6, 7, 8, on and on and on and on. Same thing here then with this 3/8 scale is I only have every other foot labeled, so it's 0, 2, 4, 6, but I can borrow this one to be 1 foot, 2, 3, 4, 5, 6. Now if we're getting into a much larger scale, so this is 3 inches equals a foot on paper, so that means from here to here, this is 3 inches on paper. It's 1 foot in real life then. So we are then, or excuse me, it would be just 3 inches, but it would be the equivalent of 1 foot. So now we're getting a much larger scale, and it's going to get a lot less can fit on just our physical architect scale in our hands, but we can always move it and slide it over. But typically you're not going to be doing super large areas of your drawing in 3 inches equals a foot. This is going to be where you have detailed portions of a section to really be able to understand all the different nooks and crannies of how that skylight is installed or how the door fixture works. So how do you use a scale? To read a line, you are going to align the 0 of the scale with the end of a line, and you'll note the foot mark that it completely passes. So in this case, I've got this red line here, and my scale at 1 inch equals a foot completely passes the number 2. So it's 2 feet. Then I would slide the scale over. So now it's at the edge of 2 feet. And then I would note how many inches. So this line would be 2 feet, 3 inches at 1 inch equals a foot. Now when creating lines with a scale, we rarely ever want to actually draw with our scale. We just use it to make notations for amounts, and then we would use a straight edge to draw with it because we don't want to muddle up the edge with like pencil or marker, things like that. Typically what I'll do is if I knew that I wanted a line to be, let's say at 1/4 inch equals a foot, I wanted it to be 11 feet and 7 inches. What I would do is instead of starting my line at the 0, I would start my line at the 7-inch mark, and then I would draw myself to 11 feet. So instead of starting at the 0, I just start at whatever inch mark I knew I wanted to start with. So drawing with the scale can be a little bit easier than reading with it. And especially then, a lot of times at these smaller scales, we'll get a couple of different readings. So I'll do an exercise with my students where we read different lines, and we'll have differences of about 2 or 3 inches from what I think the number is and what they think the number is. And that's why it's super important to have those dimensions on the drawings. So you're not relying on just reading the number with the scale. Now the 1/4 inch equals a foot scale again is the most popular one that we're going to use in sets of plans or drawings. So that's why I encourage you to get a 1/4 inch graph paper. So that way if you didn't have a scale or didn't purchase one, you could still just use the 1/4 inch of the graph to kind of help lead you along the specific sizes or amounts on your drawings.